Hi everyone, it's Coach Fred here, and I got a couple questions on the Trig worksheet that says special right triangles and right triangle trig review in Algebra 2 Honors. So I'm looking at specifically at question number 11. Okay, and so here we have, we're supposed to write a trig equation and then solve for the missing variable, which in this case is j. And so the way I handle these is I remember my ratios using SOHCAHTOA. Remember, that's just a mnemonic to help us recognize the ratios that come into play with sine, cosine, and tangent. So then I actually mark the angle and I say, in reference to this angle, I want its adjacent side and I have the hypotenuse. So adjacent and hypotenuse tells me I'm going to use cosine. So I fill in the trig equation for that. So it's cosine of the angle, so cosine of 48 equals j over 21. Okay, now you have to remember this is a proportion now, right? So you can clear fractions by multiplying both sides by 21. And so you would have 21 cosine 48 equals j. And you'd put that into your calculator and you'd get an estimated, an estimated decimal. I forgot my calculator, so I'm going to ask you to do that for me. All right, also wanted to take a look at question number 13 on the third page, where this one said find the exact value. Now, I want you to key in on the fact that you have a 60-degree angle and a 45-degree angle. And so in class the other day, we were talking about how a lot of the work we're going to do with trigonometry and the unit circle are going to involve 30, 60, 90 triangles and 45, 45, 90 triangles. So I tend to look for very key angles. I look for 30s, I look for 60s, I look for 45s. I also look for 120s. Well, why 120s? Because if I bisect 120, I get 60. I look for 135 because 90 and 35 add to 45. So I might be able to see a 45-degree angle in there. But on this particular question, I see the 60 and I see the 45. So let me just remind us that in a right triangle that's a 30, 60, 90 triangle, the side opposite 30 is the short leg. The long leg is across from 60, and that relationship is s root 3, and then the hypotenuse is 2s. So I first very carefully locate the side that I have a value in, and that is the side opposite 60. So that is the side that corresponds to s root 3. So to work my way back to the short leg, I have to divide by root 3. And one way some teachers teach this is to set the relationship equal to each other. So 6 equals s root 3, and that helps me recognize that I have to divide by root 3. All right, so I get 6 divided by root 3. We know in Algebra 2 we have to rationalize the denominator, so we multiply by root 3 over 3. Giving me 6 root 3 over 3, and then simplifying that to 3 root 3. So now I know the side opposite 30 is 3 root 3. And then the hypotenuse would be double that, so that would be 6 root 3. Okay, now moving to the right, we can see this is now a 45, 45, 90 triangle. So we know the legs are equal, so this would be 6 root 3. And in a 45, 45, 90 triangle, we know that the legs are both x, and the hypotenuse is x root 2. So we take the legs and we multiply them by root 2. So if I take 6 root 3 and I multiply it by root 2, I'm going to get 6 root 6. So x would be equal to 6 root 6. All right, so I thought that one was a little bit challenging, but hopefully that kind of gave you some insight. And then the last question I want to go over is number 25 on the last page. And this one, they gave us a trapezoid. And as a reminder, a trapezoid is a four-sided figure with one pair of opposite sides parallel, which they gave us. They said that AB and AD were 4, and they wanted us to find DC and BC. So we have some work to do here, and so those 60 and 45s are sticking out like a sore thumb. But we need right triangles if we're going to use any of the special relationships. So I'm going to look at D, and I'm going to drop an altitude. So now I have a right triangle with 60, 30, and a 4. that's going to be helpful. So I know that across from 30 would be 2. So this little piece right here would be 2. And then this leg right here would be 2 root 3. Okay, so that's a little bit helpful, right? Now I'm going to go across to the other side, and I'm going to recognize that if I drop an altitude going up, I have a 45, 45, 90 triangle. And since I've created a rectangle, then this would have to be 2 root 3. Okay, now a couple things. If we know the whole length of AB is 4, we know this side is 2. So up here, I know this side is 2. Okay, so now I've got to work with the other part. So I have a 45, 45, 90 triangle. It's isosceles. That makes this 2 root 3. And then to find the hypotenuse, BC, I multiply 2 root 3 times root 2, giving me 2 root 6. All right, so let's put that all together. So DC would be 2 plus 2 root 3. That would be its exact value. And BC would be 2 root 6. All right, hopefully that was helpful. They get really, really tricky. So just again, look for 30s, 60s, and 45s. And remember, from any point to a line, you can drop in one perpendicular segment called an altitude. All right, hopefully that was helpful. Have a great day.